In today's lesson, we're going to look into answering open-ended science questions. Hi, I'm Mr. Long and I'm a science teacher today. Now, I'm sure for parents who are looking at this video, sometimes you wonder, why is primary school science so difficult these days? Or at least it seems to be difficult. That we can see news articles that even some parents go for tuition to help their students, their children, And this becomes apparent when we look at articles like this as well. Sometimes parents and a lot of people wonder, is there only just one answer for science? And my short answer to you right now is no. There can be more than one answer. It depends on how you justify it, how you explain it. And in this lesson, I'm going to go into 2 science tips. The first one, which I'll just cover very briefly today, is about science concepts. Now let's take a look at this question. This clearly, for those who are familiar with this and those who have studied, this is a life cycle question. And the question is very direct. Name the stages B and C. And the expected answer for B will be, this is a 4-stage life cycle of a butterfly. Alright, and B clearly is a larva stage, and C clearly will be the pupa stage before it transforms into an adult butterfly. But look at what the child wrote. For stage B is a worm, and stage C is what? Sun Gui. What is Sun Gui for those who do not know? Well, this is a Sun Gui. Now, why do you think the child wrote that? To me, my understanding is this. The child wrote that because the child doesn't know what the question was asking for. And they couldn't connect what they were reading, which are all the words there, to the science concept being tested in this question, which is about life cycle and the stages in life cycle. That is why they end up with hilarious answer and very sad too, such as this. Now, to connect to science concepts, students must know the meanings of words used in science. Now, I'm very certain that many of my students, or many students watching this video, you are excellent readers. You read lots of storybooks. However, that is a different text type. Storybooks are narrative. But science questions are not, because they are science words and science diagrams. They are not meant to be used in a daily life. Let me give you some examples. Like when you're reading science question, there are several kinds of text features that you find special to science. For example, there are vocabulary unique to science, such as hypothesis, pollination, fertilization, words that you do not use in your everyday language. And you will find vocabulary sometimes with different meanings used in science. For example, light at home refers to the lights from your lamps, but light in science refers to a form of energy. And light can also refer to something that is the opposite of heavy. Like population in day-to-day use could mean the number of people in a country, but population used in science at P6 will refer to the number of living things present in a particular habitat. And cycle, when you use cycle, typically you're talking about riding a bicycle. I'm going to cycle to school. But in science, cycle refers to repeated patterns of change that allows you to make predictions. Sometimes you will find, very often you will find science diagrams and symbols that require you to make interpretation. You need to infer cause and effect relationship, which we will cover a bit in the later part of this video. You need to infer main ideas and draw conclusions from a question like this. And you need to use deductive and reasoning skills. These are the skills required when you're reading science questions. So no wonder a lot of students who struggle with science questions are actually good readers themselves. So English is not the only thing. You must first understand that science questions comes with many features. But the simple thing is this. Once you understand all these features, reading science questions is very easy. The second tip now, which I have always mentioned, is about knowing the meaning of words. And that you must know that words can be used to ask questions in all topics. And these words, such as the one I list below, are really, really important. Right? Because you know that words have meaning. And these words, for example, explain, observe, relationship, variable. For example, based on the table, based on the graph, based on the diagram, or the aim of the experiment, or words such as function of an object, the characteristics of a living thing, the type of material, give an example, state an example, what is a fair test, what are changed variables. These are all words that appear in almost every science test. And sometimes the meaning appear but the words do not. In this particular video, we're going to cover just a few of these words. We're going to talk about words such as variable. We're going to talk about aim of an experiment. We're going to talk about changed variable. We're going to talk about same or constant variable, as well as fair test. Now, later on when looking at questions, I will ask of you to pause the video first, or your teacher using this video, please pause the video. Let the students try the questions on their piece of paper before proceeding to look at the explanation. Now let's start with the simpler words, variables. For example, in this question, Siti plants 3 similar young plants in 3 pots, P, Q, and R, filled with the same amount of garden soil. The plants are watered with equal amounts of tap water daily. She provides different amounts of the similar nutrients to each pot. After 4 weeks, she measures the increase in the height of the young plants and records them in the following table. So you see the 3 different pots here, amount of nutrients given daily, as well as an increase in the height of the young plant. Now you may pause the video here now and try to identify the variables. Of course, if you do not know what variables are or you're not very clear, then you don't pause the video, you carry on watching for a while more. Now when we talk about variables, there are 3 different kinds of variables. Sometimes books or your tutor may use big words such as independent variable, dependent variable, measured variable. I'll keep things simple for you. You just talk about variables that are kept constant, variables that are changed, variables that are measured. So we see things like 3 similar young plants. Same amount of garden soil. Watered with equal amount of water. Alright? And all these words like similar, same amount, equal amount. Very straightforward. They tell you these variables are the ones to be kept constant. What is the second type of variables you look out for? There are things such as different amounts of the similar nutrients and different amounts. So what is changed here is not the type of nutrients, but the amount of nutrients. Alright, so we know that this amount of nutrients will vary. The amount will vary. So we can see from here, for pot P they use 10 ml, for pot Q they use 15 ml milliliters, and for pot R they use 25 milliliters. And what can we tell from this? This is the results. The results that this person, Siti, wants to measure. She wants to find out if when she changes this variable about the amount of nutrients, will it cause an increase in the height of the plant, and how much increase would that be? So she will look at it, 10 to 12. Also, when you put 10 ml, it grows to 12 centimeters. After 4 weeks, if she put 15 ml, it will grow up to 19 centimeters after 4 weeks. If she put 25 ml, it will grow up to 28 centimeters after 4 weeks. Let's practice now. Practice identifying the constant variables, the change variables, and the results. Now, please pause the video here. Test yourself. Write down this on a piece of paper. Which are the variables that are kept constant? Which of those that are changed? And which of those are results? Once you have gotten the answer, then you can press play. Alright. Now, Raj wants to test the strength of 3 shopping bags, X, Y, and Z. He places loads of similar masses on each bag until it tore. He records the result in the table below. So, bags here, maximum loads added before the bag tore. Now, for those who are familiar with this key term, this idea here, this idea tells you they're testing about the strength of the material. But let's focus on the practice here. Where are the constant variables? Now, notice the loads are of similar masses. So when we can compare here, 1 load definitely has fewer kilograms than 4 loads. 6 loads will have fewer kilograms than, more kilograms, than 1. So these are loads of similar masses, and I'll presume here each load is equivalent to 1 kilograms. So that will be the constant variable. Now what about the changed variable? I notice here that there are 3 shopping bags, and the 3 shopping bags X, Y, and Z here are different. So what is useful here? Alright, so 3 shopping bags are different. Therefore, that would be the change variables. There are 3 different shopping bags. Okay? Now, so we notice 3 different shopping bags. That will be the change variable. So what will be different about these 3 different shopping bags? Of course, they're of different strengths. And what will be the results that are measured and recorded in the table? Well, this will be the results. The number of loads added before the bag tore or broke. Right, of course, bag Y will be the strongest bag because it took the most number of loads to tear it. Okay, great. If you have identified all the constant variables, change variable and results correctly. Now, let's look at what is aim and change variable. By now, I'm very sure all of you can identify aim of an experiment easily. There's certain words that tell you which is the aim. For example, Tina wanted to find out whether plants will grow well in different places. That already tell you this is Tina's aim. Okay, but let's be more specific and go into what is a changed variable inside. By pairing up this identification of aim and change variable, it will help you understand the question so much more. Okay, and what I've highlighted in blue will be the constant variables. There are 2 similar types of plants. Alright, when you look at similar, let's see. And if we use same amount of water to water them, okay, there is a constant variable still. And when I look at the pictures, I must also make comparison. I look at the shape of the plants, it looks similar. I count the number of leaves, 1 here, 3 here, 3 here, 3 here. And I counted the number of leaves are the same as well. So this can tell me the type of plant is the same. Then where is a changed variable? I look at plants will grow well in different places. So whether the same plants will grow better, will grow well in different places. So I must see that there is a different place in this experiment. So I look at this, yes, the setup A, 1 is placed in a dark cupboard. Dark means that there is no light at all. In science, dark means that there is an absence of light, totally. And for setup B, is placed in a school field. So school field is an open area, exposed under the sun, so definitely it will be bright. Okay, now, did anyone spot a problem? Because if you have, then you are very good at reading science questions. You may pause the video here to see if you can spot the problem with this question. Have you? Do you notice that these 2 pots are of a different size? And we talk about the change variable. There should only be 1 change variable in every experiment. So since the change variable should be the different places, which you already have, why is there a different size pot here? That is a problem. Alright, please note that if you can spot 2 change variables, you will know that something has gone wrong with the experiment. So if the question asks you, how can you improve, how can you help Tina with her experiment, so she can come to a good conclusion, a fair conclusion, then you can tell her, oh, she needs to change this pot to a pot of the same size as setup B. Because if having different pots may also mean having different amounts of soil. If there's a different amount of soil, therefore you can also say, oh, the plant growth is affected not just by the location, but also by the amount of soil. And then you cannot come to a good conclusion to this aim. Now, let's look at a second example, practicing identifying the aim by identifying the change variable. So you may pause the video here, read the question and try it. Okay. Raj then carried out another experiment to test 3 similar rulers A, B and C of different materials. He tested each ruler by placing one end of the ruler on the tabletop and hung a weight on the other end. He then measured the distance D as shown below. Alright, he repeated this experiment with 2 of the other rulers. He then recorded the results in the graph as shown below. Distance D, alright, this is the shortest distance, this is the longest distance, so in other words it bends the most. Alright. And these are the 3 different rulers. So, what is the aim of Raj's experiment? Well, Raj's experiment is to find out, remember, we look for the change variable, right? Find out, oh, it's similar? No. When it says similar rulers, it just means that the length is the same, the thickness is the same, maybe the color is the same, but the material they're made of the material is different. So therefore, the change variable here will be the different materials. So the aim of Raj's experiment is to find out which material. But that is not all that is to the aim. Which material what? Because this question is special. It didn't tell us what is the aim of the experiment. And sometimes you're asked to tell us what is the aim. So we must read on and look at the picture, look at the graph. And we notice that the recorded result here is about this distance d. Alright? And that tells me that this distance d is what Raj's measure. So that is his measured variable. So this must be an important outcome of his experiment. So he wants to find out whether which material can do what. What does this tell him? Whether which material can bend the most. And bending tells us this property that Raj is trying to find out, trying to investigate, is the flexibility. You're right, flexibility of the material. So which material is the most flexible? So let's put it together. If the question is, what is the aim of Raj's experiment? You will write down, the aim of Raj's experiment is to find out which material is the most flexible. Let's look at one more example. And this time we're going to cover the term fair test. Now, what is a fair test? Now, so if you look at this question and you ask yourself, is Joshua's experiment a fair test? You may pause the video here, read the question, and try to answer this. Is it a fair test? Now, when we look at whether an experiment is a fair test, we must look at, we must first understand the idea of fair test. Is to find out what can affect the results. So when a person is doing any experiment, is to find out what can affect the result. That person only want to look at one change variable. What will changing one thing affect the results? So by changing only one variable and studying the results, this person can conclude that whatever happened to change the results is caused by the change variable and nothing else. So to do so, to know whether it is a fair test or not, we must identify the aim, the change variable, and the results. Let's take a look. Where is the aim? Clearly, this is the aim he wanted to test how? To find out. And where is the change variable? You're right, the amount of light. That is the change variable. And let's confirm it. We notice that the lamps are of different light intensity, so they are of different brightness. Alright, and the amount of light here did change. Alright, from the dimmest to the brightest. And then we look at what are the results. The length of the stem of the bean plant. That length of the stem is what Joshua was measuring. And let's see. Alright, yes, he did try to measure the length and he recorded them here. So that is the results. Knowing this is not enough to tell me is this a fair test. We must also look at what are the constant variables. And here we must make some fair assumptions. Alright. So we look at 5, 6, and there's no mention that they're of the same type, but I will presume they're the same type because they look the same. Okay. And also if we talk about 3 pots, there's no mention that the pots are of the same size, the amount of soil are the same. I will presume that they are the same. That's the only way this experiment can be a fair test. Alright, so the amount of soil, I'll presume the same type and the same amount. So we must make some fair assumptions sometimes. Otherwise, this question will be super long. If all these words were to come in, 5 seeds are the same type, 3 pots are the same size, with the same amount of soil, this will be a very, very long question. So, is it a fair test? Well, a fair test has only one change variable, and the only change variable here is the amount of light. Nothing else has changed if my assumptions are correct. Therefore, yes, this is a fair test. So let's summarize this lesson. We have learned to understand the following words in science questions: variables, constant variables, changed variables, results, aim of the experiment, and fair test. We have also learned to identify the aim of the experiment by looking for the changed variable and the results. And we have learned to identify if an experiment is a fair test or not. In the following lessons, we will learn more about other words. Remember, words have meaning, and if you know the meaning of the words, you can piece them together, you'll get the clues that your teachers have placed kindly in all your science questions. All the best.